Can you hear me?
Yeah, I can hear you.
Okay. Our topic is isomerism.
Yeah.
Isomerism, the word is written here as iso. Iso means same.
Okay.
Isomerism is a property of organic compounds in which they have same molecular formula
Okay.
and different structure formula.
All right.
So what is the molecular formula? Do you know?
Yes, molecular formula is what atoms make up the compound. So they'll both have like two carbons and three hydrogens, for example.
Okay. If we see in a short term, molecular formula is that formula that tells number of atoms present in a molecule or a compound. Okay.
Okay. Yeah.
So if we say methane, methane formula is like we can say its formula is CH4.
CH3 4.
Methane formula is CH4. So it is the molecular formula of methane because it has 5 atoms. One is carbon, 4 are hydrogen. Like we said,
Okay.
structure, carbon can form 4 bonds, and there are 4 hydrogen that are single bonded attached with that carbon. So this is a structure formula, and this is a molecular formula. Okay.
Yeah.
But isomerism is that property that has same molecular formula and different structure formula. We can explain it with one another example like we can say uh, this 4 carbon compounds is called a butane. Okay.
Yeah. Okay.
So you can arrange this because carbon can form 4 bond, then you have to make 4 bond. 1, 2, 3, 4. Okay. So
Okay.
they are single bondly attached with the hydrogen.
Okay.
So this is the structure formula of butane.
Butane.
Now likewise, I make another compound of isomerism of this.
Okay.
No, you have to make like this.
Okay. Do you want me to make one?
Okay. So
Okay.
you have to make one branch.
All right.
So there are also 4 carbon. Here are also 4 carbon. Then every carbon makes 4 bond. Okay.
Yeah. Okay.
Then you have to arrange a hydrogen with this. So you can see here number of carbon present in both molecules are same. Here are 4
Yeah.
carbon and here are also 4 carbon. You can
Yeah.
count hydrogen. Hydrogen will be also same, uh, 4 for a 10. Here are also 10 hydrogen. You can count. Okay. But
Okay.
you can see that uh, number of atom present same. It's mean molecular formula is same,
Okay.
but structure is different. This is called isomerism. So when molecules are arranged in a straight chain, this is called N. So number of carbon 4. So there is no double bond. So it will be the alkane. So we can say it is called N-butane. Okay.
Okay. Yeah.
When there is one branch, that one branch is said as so. So there are
Okay.
4 carbon, 1, 2, 3, 4. That will be the
Yeah.
butane. Is it clear?
Yeah.
So this is a simple example of isomerism. A molecular formula is same, but structure formula is different.
Okay.
So if we say of alkane member like Methane. First is methane. Its formula is C4. And second is ethane.
Okay.
And third is propane.
All right.
Methane has 1 carbon, ethane has 2 carbon, propane has 3 carbon.
Yeah.
These compounds have no isomerism.
All right.
Because when you arrange their structure, you can not draw different structure. All
Okay.
structure will be the same, but isomerism is that have most different structure. Their molecular formula same, but structure formula different. So isomerism in alkane start from butane. Okay.
Okay.
So isomerism is divided into two types. We can say we have to discuss the property types of isomerism.
All right.
One type is structural isomerism,
Oh, this geometric.
and second is cis-trans or geometric isomerism.
Yeah.
So firstly, we discuss the structural isomerism.
Okay.
Structural isomerism. If we see structural isomerism, in
Yeah.
structural isomerism, there will be difference of structure.
Okay.
But number of atom or molecular formula will be same.
Okay.
Difference of structure mean arrangement of atom. Arise due to different arrangement of atom. Okay.
Okay.
So we see there are 5 types of structural isomerism. We have to discuss first.
All right.
First type is called position. First type is called chain isomerism.
Okay.
Chain isomerism arise due to difference of carbon atom chain. Okay.
Okay.
So we can explain like its example, N-butane or also pentane.
Okay.
we can explain it like pentane. Pentane has how many number of carbon?
5.
5. So this is the straight chain carbon, we can say. You can make its other bond, and you can write hydrogen here. It is up to you. So it is straight chain. We can say it is an pentane.
And
So you can draw its another structure. So each carbon makes 4 bond. So when there is one branch, its name will be azo. So there are 5 carbon, its name will be azopentane. And you can make another structure.
do you want me to make one?
You have to make another structure like
Okay.
you arrange 3 carbon like in series and 2 carbon in branch. Okay?
2 carbons. Okay.
Yes. So each carbon has ability to make 4 bond because its valency is 4. It makes 4 bond to become stable. So when there are 2 branches, its name will be neo.
Okay.
As if you can see, pentane makes 3 different structure. It's
Okay.
mean pentane has 3 isotope, 3 isomerism.
Yeah.
Is it clear?
Yeah.
So firstly, we explained the example of butane. Butane has 2 isomerism. And
Yeah.
if we see like here we say methane, ethane, propane has no isomerism. But
Yeah.
isomerism of alkane started from butane. So butane has 2 isomerism and
Okay.
pentane has 3 isomerism. So we can
Alright.
say this is the example of chain isomerism.
Okay.
So we have to explain another example.
No, I think I understand it.
You want to explain another example of this?
Can you explain what trans-cis isomerism is?
Cis trans.
Yeah.
Okay. Now we have to explain cis trans isomerism. Cis trans isomerism is also known as geometric isomerism.
Okay.
Geometric isomerism.
Alright.
If we say cis trans isomerism,
Yeah.
it has same molecular formula,
And different structural formula.
number of atoms will be the same,
Yeah.
but same structure formula.
Okay.
But different will be the position of groups in the space.
Oh, okay.
different position of groups in space. Okay.
Okay.
Now we have to explain it with example. We
Yes,
have to
please.
explain 2-butene.
Okay.
So you can see there are, it is butene, it must have 4 carbon.
Yeah.
So 2-butene, it's mean double bond will be number 2, if you count from here. So each carbon makes 4 bond.
All right.
But when we explain in term of cis-trans isomerism, you need to make this structure like this.
Okay.
You can see it has hydrogen attached with this,
Yeah.
and you can see CH3 is attached with this carbon. Okay,
Okay.
so you can say the number of atoms in the space in the upper side, 2 hydrogen, and both are the same atom, and lower side carbon. So when a number of atoms in the space are same, we can say it is cis alkene, cis butene or cis alkene, because alkene we can say due to presence of double bond.
Okay.
So you can draw its isomers like due to difference of position. You have to write like same, but you have to change position. You replace hydrogen at CH3 and CH3 place at hydrogen place. Oh, sorry. Here is hydrogen. So same structure I draw, but I change the position of this.
Okay.
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 So when different atoms are present in the space, we can say it is a trans. So it will
Okay.
be the trans alkene. You can see here, if we explain it, same atom are present in the space. This is called cis, and this you can explain as different atom are present together in the space.
All right.
Okay. So
Yeah.
concept from this structure is very important, but this carbon must have 2 different atoms. You can
All
see in
right.
cis, you can see in the cis, this carbon is also attached with different atom. This carbon is also attached with different atom. This carbon is also attached with different atom. You cannot place hydrogen here and hydrogen here.
All right.
Okay. So, but you have to see different orientation of groups in the space. So this is called cis-trans geometric isomerism. We
All
can
right.
explain it in terms of halogen. If you want to explain another example, this carbon is attached double bond, and it is attached with CH3, and it is attached with chlorine and bromine.
All right.
So halogen group are present in the same space, and with
Yeah.
carbon atoms are present in the same space, we can say it is a cis.
Okay.
Then you can make it trans. You need to change position of one atom. Like you change this position with this, and bromine goes to up, and CH3 comes. So different atoms are present in the space.
Okay.
So it becomes trans.
All right.
If we check the stability of cis and trans, the trans are more stable than cis. Because
Yeah.
in trans there are different groups are present in the space, and they provide conjugation and provide string to the carbon, and so they are the stable.
Okay.
Is it clear?
Yeah.
So give me the another types we have to explain it.
Um. So do you want me to draw one? Do you want me to draw one?
Okay, you have to draw one structure like one cis and one trans on the base of hydrogen and halogen. Okay.
Okay. That's the BI. It's just a bit messy. So this is cis because these two are in the same present in the same area, and then let me draw this. And then this is trans.
Okay, good. So from these two structure, which one is more stable?
Uh, is it cis?
No, no. Trans is the most
Oh,
stable. Okay.
trans. Okay.
So can you give the name of these compound?
The names. Oh, okay. Is it
If you want to give the name of this,
is it cis
you have to place
bromo?
numbering firstly.
Oh,
So you can write here 1, 2,
cis bro
dibromo.
dibromo.
So 2 carbon,
Ethene.
ethene. Is it clear?
Yeah.
So it is the name of this compound.
Okay.
So you can give also name different compound that are given explained earlier,
Okay.
like this. What will be the name of this? You have to write name of this.
Okay. Oh, let me do it more. This this one is one. This one is two. That's a dash there. I just actually joined it. Two chloro no ethene. Let me stop it more. Um, butene. Well, that's really messy. I'll rewrite that.
No, firstly, you have to see, select the carbon chain when you are naming any compound. Okay.
Okay.
So you see that it's this chain is starting from here. One,
Yeah.
2, 3,
Three.
4.
Oh,
And
yeah.
also
It's
you can start
two.
from, now you have to give the name.
Oh, okay. I realized now. I thought it was ethene when I started, and it was just butene afterwards. So I did this part wrong. I just have to. 3. Oh, well, I don't know.
And you have also mentioned double bond, 2 butene,
Yeah.
2 bromo, 3 chloro, 2 butene. It's mean double bond present on the position 2.
Okay.
Okay, good. So you can give the name of this.
1 second of this. All right.
This. You have to
Okay.
write at this position, right?
So 1, 2, 3, 4. Would it not just be butene? Or that says cis-butene?
Okay, good. So now we have to explain another example of another type of structural isomerism is functional group isomerism. Have you heard about this name?
Yeah.
Now we have to explain that after this functional group isomerism. Functional group isomerism is the type of structural isomerism.
Okay.
So it will have same molecular formula and different functional group.
Alright.
Can you define a functional group?
A functional group is the homologous series that is when oh wait 1 second. I'm not sure.
Atoms, group of atom, double bond, triple bond, whose presence imparts specific properties to organic compound is called functional group. Okay.
Okay.
So we have to explain the example of functional group isomerism.
Okay.
Functional group isomerism, when arranged, it shows its structure alcohol and ether. There will be one alcohol functional group and other will be the ether. If I draw a structure for alcohol like this, alcohol is that compound that has OH must. So there will be the two
Okay.
hydrogen and here will be the three hydrogen. Its name will be ethyl alcohol.
All right. Yes.
And you have to draw another structure of this like
Okay.
so each carbon can make 4 bonds, so it need to make three more bond. It will attach three hydrogen, and this carbon will attach three hydrogen. You can
Okay.
count carbon. There are two carbon, here are two carbon. There are
Six
six hydrogen,
hydrogens here.
here are also six hydrogen. There is
Yes.
one
And one
oxygen here.
oxygen.
There was. So their molecular formula is same, but you can
Yeah.
say, and this is alcohol and this is ether. So what will be the name of this? There are two methyl group. Its name will be dimethyl ether. Dimethyl ether. So same molecular formula and different functional group. It has alcoholic functional group and it has ether. Okay.
Yeah.
Is metamerism is given in your book? Metamerism
Um.
types.
And I'm not sure.
Metamerism, or you can say another type, because there are multiple types. I want to explain that are given in your books.
I don't think we get them in our books, as far as I know.
I have to explain
We,
metamerism in short term.
yeah, because we only have our first book right now. We're still to get our second book. We haven't received it yet. So
Okay,
then the one that I have, that is
I
in it.
have explained it with one example because metamerism is also important.
Okay.
Maybe it is present in your book. Metamerism. Metamerism arise due to unequal distribution of carbon atom on either side of functional group. Now we have to explain it with an example. If I say there is ether, so you know that each carbon makes 4 bonds. You need to place three hydrogen, and here two bond are already made. Then you will
Got
place
two
two hydrogen,
hydrogens, and then two hydrogen here, and three hydrogen on the last one.
and here will be the three hydrogen. So what will be the name of this?
Um, one, two. Oh, is it butanol?
So firstly, we have to explain it's another structure like oxygen is given with one carbon, then you place oxygen after two carbon.
Okay.
So here will come three hydrogen, here will come two hydrogen,
Okay.
and here will come three hydrogen. So you can
Okay.
say distribution carbon atom on either side of functional group is different. So this central is oxygen, and the right side there are three carbon, and left side there is one carbon. And you can see here, oxygen is present at the center, and two carbon are present on the right side, and two carbon are present on the left side. So this is, we can say, this is the distribution of carbon atom, unequal distribution of carbon atom on both sides.
Okay.
Because you can say when you draw the another structure from here to this, there become unequal distribution of carbon atom. So there is one carbon, so there are three carbon, so it is unequal. When there are same number of carbon present on the same functional group, we can say it is equal, but it is
Okay.
unequal because one side are three carbon and one side is one carbon. Is it clear?
Yeah.
No, we try to give the name of them.
I'm not sure,
Okay, I provide you the name of them.
please.
You have to see structure firstly. It is methyl.
Okay.
One carbon is methyl.
Okay. What then this is
This is a N-propyl because it is present in the series.
okay.
Three carbon is
So
called methyl N-propyl. When there is oxygen between two atoms, that molecule is called ether. Okay.
okay, so would this be
You have to try to name of this compound.
methyl and methyl yeah, that
So
is that right?
when you are trying to naming of any compound, firstly you see a number of carbon are present on both sides. Then you can write in the term of di. Okay.
Okay. Oh
So
yeah, it's di and ethyl, isn't it?
diethyl.
Yeah.
Okay.
Wait just a minute. Oh, is that right?
When there are same, then you don't need to place N.
Okay.
Okay. So its name will be diethyl ether.
Okay.
So we have to explain one more example of this and then we end the lecture. Okay.
Okay.
This example was explained on the base of ether. Now we try to explain on the base of carbonyl compound like ketones.
Alright.
This is a compound, 5 carbon compound, and this is carbon double bond oxygen. This is called functional group carbonyl ketone. Okay.
Okay.
So you will place three hydrogen here, and you will place two hydrogen here, and there is no need to place one hydrogen because four bond of carbon are made already. Okay.
Okay.
Then it will have two hydrogen. It will have three hydrogen. What will be the name of this?
Um, one, two, three. Oh, okay. Where's the pen? I'm not sure because this extra carbon
Okay, you
here.
have to see. Um, this is ethyl.
Yeah. So
This is also
diethyl,
yes di.
and would this be a
This is
methyl
called
group?
ketone, diethyl ketone.
Oh, yeah,
Have you got?
yeah.
No, you can write this compound. Uh, you have to change the position of functional group. You have to
Okay,
put this side. So here will come 3 hydrogen. Here will come 2 hydrogen. Here will you place 2 hydrogen, and you will place
okay.
3 hydrogen. And there is no need to place any hydrogen. So what will be the name of this?
Will it be methyl and propenyl ketone?
No, ether. Ether is not.
Ether, sorry.
It will be ketone. Okay.
Yeah, methyl and propenyl ketone.
So you can see uh, there are same number of carbon present on the same of either side of functional group, and there is unequal distribution of carbon atom on either side of functional group. Here are 3 carbon, here are 1 carbon. So it is
Uh,
called metamerism when there is unequal distribution of carbon atom on either side of functional group. Is it clear?
okay. Yeah.
So do you have any query about this isomerism?
No, no, thank you.
Okay, but thank you and take care.
Right, right, that's
Love is.